Welcome dear students. In this video I will discuss friction is both problematic and useful in many applications. So whenever there are some moving parts like in IC engine, piston and cylinder, they have relative motion, similarly journal and bearings. So in that case we want less friction so that we have less losses. Although friction is also useful in many applications like it is helpful for you in the walking process. When you walk, then you need friction. It is very difficult to walk on a slippery surface. Then when you are writing on the board with the help of a chalk, then again friction is useful. Then for braking purposes, then if you want to pull some water from the well and for placing a ladder against a wall. So these are some of the applications where friction is useful. Now let us introduce. In previous chapters of mechanics, we assumed that the surfaces were either frictionless or rough. Okay. So in when the surfaces are frictionless, surface could move freely with respect to each other, and when they are rough, tangential forces prevent relative motion between surfaces. Now actually no perfectly frictionless surface exists. So however smooth the surface may be, it has some friction. For two surfaces in contact, tangential forces are called as friction, and they will develop when one attempts to move one surface relative to another. Now the frictional forces are limited in magnitude and will not prevent motion if sufficiently large forces are applied. So whenever you apply some small force, then your body will not move. Or when you apply large forces, then body starts to move. So frictional forces, they cannot prevent motion. Now the distinction between frictionless and rough is therefore a matter of degree. Okay. So if the force is very large, so you can say that the surface is frictionless, and if you are applying very small force, then for the same surface you can say that this surface is rough. Now there are two types of friction: dry, which is also called as Coulomb friction, and fluid friction. Now fluid friction applies to lubricated mechanism, because in many applications in engineering you are doing lubrication. Okay, so there you are using fluid friction. Now the present discussion is limited to dry friction. So in our course of mechanics, we will only deal with dry friction. Now this in this table, some of the coefficients of friction values are shown. So suppose metal is placed on metal, then this value of mu s varies from 0.15 to zero point 0.6. Similarly, if metal is placed on wood, then this value is 0.2 to zero point 0.6. Similarly, you can see other values. So for example, if rubber is placed on concrete, then this value is very high and it is varies from zero point 0.6 to zero point 0.9. Okay. And as we know, this kinetic friction force is slightly lower than the static friction. So approximately it is around 75% of the static friction force. Now maximum static friction force and kinetic friction force are proportional to normal force. So from this law you can say that these forces are proportional to the normal reaction force. Okay, and they depend on type and condition of contact surfaces, because this value of mu s, it changes with the surface. Okay, so there are two variables n and mu s. So the frictional force will depend on the reaction and the two surfaces which are in contact, while it is independent of the contact area, because in this equation there is no term related to area. So we can say that the frictional force is independent of the contact area. Now there are four situations that can occur when a rigid body is in contact with a horizontal surface. So let us see those four conditions. So this is the first condition, when this force is applied from the top. Okay, so in this case we have the weight, we have the normal force, and since it is applied from the top and block cannot move in the bottom direction because of this restrain. Okay, so we can say that in that case frictional force is 0. Now second condition is that when this force is applied at certain angle. Okay, now we can reduce this force in two components, px and py, and in that case there will be some frictional force, and suppose there is no motion, then this px will be less than f, because f will be equals to px and f is less than mu s by n. Now n is equal to py plus w, because this one component will act with w to counter this n. Okay, so n will be equals to py plus w. Now the third condition is that motion is impending, means motion is just about to start. Okay, so that we call it motion is impending. Okay, in that case this fx will be equals to fm. And the fourth condition is the motion, when this force is such that it imparts motion to this block. So in that case px is greater than the frictional force. So when there is no motion, then px is less than the frictional force. When motion is just about to start, then the applied force is equal to the frictional force, and when the motion is started, then applied force is greater than the frictional force. Angles of friction. So sometimes it is convenient to replace normal force and the frictional force by their resultant. Okay, so this is the first case. In this we have no friction, so the resultant force will be equals to the normal force. Now in the second case we can represent the normal force N and this frictional force F by their resultant R, and this is the angle between the normal and resultant force, and this is the angle is the phi. Okay, similarly in the third case when the motion is impending, Then again we can find the resultant R, and in that case we call this phi is equal to phi s, and this is the angle of static friction. Okay, and you can find by using the 10 law. 10 phi s will be equals to Fm by n, which is equals to mu s n by n, and so 10 phi s will be equals to mu s. Okay, so that's coefficient of static friction we can find by taking the value of tangent of this angle. Similarly, when motion starts, then we call this angle phi is equal to phi k, and this 10 phi k will be equals to mu k. Now to better understand this angle of friction, consider a weight resting on board with variable inclination theta. So this is a weight and this is resting on this board, and this board has a variable inclination. So suppose initially it has inclination 0, so in that case there will be no friction. Now suppose we move this board like this. We are changing the inclination of this board. So initially what happens, there will be no motion. Okay, now what we can do, we can break the forces in the components. So this force is W sine theta, this force is W cos theta. Okay, similarly we have n will be equals to W cos theta because this will balance, and F will be equals to W sine theta. Now at one point what happens, if you continue to increase this angle, that and one point what happens, the motion is about to start. Okay, so means motion is impending. Okay, so in that case we call angle this theta equal to theta as the angle of repose. Okay, and this is equals to phi r, which is the angle of friction. And when the motion starts, then this theta will be greater than theta s. Okay, so when your this theta means the angle of inclination of this board is greater than theta s, then this motion will start. To solve the problems involving dry friction, so sometimes you have this type of case where all applied forces are known, coefficient of static friction is also known, and you have to determine whether body will remain at rest or slide. Okay, so sometimes you have to solve these type of problems. Then another case might be all applied forces are known and motion is about to start, motion is impending, and you have to determine the value of coefficient of static friction, that is you need to find the mu s. So in that case, first case you need to calculate the frictional force. Okay, in the second case you need to calculate the mu s, and in the third case the body is moving, so coefficient of static friction is known, motion is impending, and you have to determine magnitude or direction of one of the applied forces. So you may need to find the direction of P, magnitude of P, or any other applied force. So this is how you can solve the problems involving dry friction. One sample problem. So consider this block on this inclined plane, and in this block 100-pound force is applied. The coefficients are given, mu s is equals to 0.25 and mu k is equal to 0.2. Now we have to determine whether the block is in equilibrium and find the value of frictional force. So these are the steps. First we will draw the free body diagram. Okay, and remember that the friction force is opposite to the direction of impending motion. So in whichever direction you know that the block will move, so then you will apply the force, frictional force in the opposite of that. Then Next step is to determine values of friction force and normal reaction force from plane required to maintain equilibrium. So we will suppose that suppose the body is in equilibrium, and then we will calculate the frictional forces and normal reaction required for equilibrium. And what we will do next, we will calculate the maximum friction force. Maximum friction force can be calculated from Fs is equal to mu s into n. Okay, so we will calculate the maximum friction force. Okay, so if it is greater, block will not slide. So friction force is greater, then block will not slide. And if maximum friction force is less than the friction force required for equilibrium, block will slide. Okay, so we will calculate the forces for maintaining equilibrium, and we will calculate the maximum frictional force. So if maximum friction force is less than the friction force for equilibrium, then block will slide, otherwise it will not. So let us solve the problem. So this is the free body diagram of the problem. So this weight will act vertically downward, and n is normal to the surface, and this is the applied force. And suppose because force is applied in this direction, so we are supposing that the motion will be in this direction, so the frictional force will be opposite to this, so the friction force will be in this direction. Okay, so now suppose we are supposing the equilibrium, then for equilibrium summation of fx will be 0, summation of fy will be 0. So suppose this is our x direction. Okay, so in the x direction we have this force, applied force, then we have one component of this weight, and then we have the friction force. So from friction force, from this we can find F is minus 80 pound. Okay, similarly we can calculate Fy. So in the y direction, which is this direction, okay, this one, so we have n, then we have one component of this weight, so n minus 4 by 5 of 300 pound, so n will be equals to 240 pound. So these are the conditions for equilibrium. Okay, now sign means that this force is opposite. Okay, now we can calculate the maximum frictional force with this formula. Okay, so now we know the n and mu s is given in the problem, so Fm is the 60 pound. Okay, so now your maximum frictional force is less than this force, so that means the block will move. Okay, because this force is less than the force, so that means the block will slide down the plane. Okay, so now if maximum friction force is less than the friction force required for equilibrium, block will slide. So actually now since block is sliding, okay, so now the frictional force will not be equals to the maximum friction force, but it will be equals to the kinetic friction. Okay, so we need to calculate the kinetic friction. So kinetic friction will be equals to Fk is equal to mu k into n, and Fk is 0.2 given in the problem. 240 we know, so actual friction force will be 48 pound. Okay, so this is how you can solve the problems involving friction. All for this video. Thanks for watching. Have a nice day.